This video will show more details on animating with Clear Motion ODS. I'm going to start with an existing project. This is a 4-stage compressor. Right now I want to concentrate on the third stage, which is orange. In the project window, if I go to solid bodies under this model, I can see 5 groups. Each group is in bold text, and inside each group I have multiple solid bodies, and I can individually turn those off by opening the group and clicking on the visible checkbox, or I can control them all at once with the box beside the group name. So I'm going to turn off everything except third stage. So if we look at this window, we can see at the top there are 3 divisions in the title. This left one says compressor, that's the name of the model that we're animating. The middle one says dataset 1, that's the dataset that is being animated here. And 12 Hz is the frequency of the animation. If I go back to the project window and click on dataset 1, this is the data that we're animating. I can control the animation frequency by holding the cursor over this gray frequency band and dragging it. When I do, the green dot shows the animation frequency at each bin, and the animation automatically changes when I change the frequency. I can change the width of the frequency band by dragging its edges. I can change the zoom and the frequency by rolling the mouse up and down, and I can also pan left and right by grabbing an area of the plot and moving left and right. If I need to control the layout of the spectrum window, I can click on the gear icon. This pulls up the graph configuration, and I can change the layout and various things about it. One thing that I sometimes want to control is whether or not I can see the phase. Right now I have the phase turned off, but I can click under the phase tab, I can click show phase axis, and now I see the phase at each point. I'm going to turn that back off. I can control the animation with the animation settings window. I click on this icon in the main toolbar and it pulls up the animation settings window. This allows me to control things about whether or not the animation is running, the speed of the animation. So I can turn off the animation by clicking on run. When the animation is stopped, I can control the phase by dragging the slider to a different phase. I can also control the playback or the animation rate. At the bottom, you can control the scaling. It's on auto scale right now, which is generally appropriate. I can also change that to auto scale overall. If I use auto scale overall, it looks at the animation amplitude at all frequencies for the auto scale. If I just use the normal auto scale, it looks at the amplitude at the current frequency. And a fixed scale factor just multiplies all of the amplitude levels, measured levels, by this number and applies them to the model. Fixed scale factor is usually useful if you're doing a comparison of 2 different data sets. I can also control how the animation is rendered with the render settings window. I can control whether or not the drawing is opaque and the degree of transparency. And the other thing I wanted to show is that you can turn on the undeflected shape here. This shows a blue wireframe of the undeflected position of each node. Finally, I want to show how you can do multiple plots on multiple views on one page. Right now we're looking at a single view, but I can change that to a quad view, and I can also do 2 views. In 2-view mode, I see that I have the same model, data set, and frequency on the right and left. And I can change that by right-clicking on a view and doing a switch model. I'm going to switch the right view to be compressor linear interpolation. And that is exactly the same as the other model, except linear interpolation is used to calculate the points instead of solid body rotation. So let's go back to the data set and switch back to 12 Hertz. And now you can see the difference between the right and left, where the linear interpolation distorts the discharge bottle. As we change frequencies, we can see that you still see that same behavior at every frequency. At this frequency, you see distortion of the bottle, the nozzles, the cylinder, the scrubber, and so this is a useful ability to do the side-by-side, so you can do a comparison of either two different models. You can do a before and after comparison of modifications that you've made, and in this case you can show the difference between linear interpolation and solid body rotation. This video just showed some of the highlights of what you can do with animation with Clear Motion ODS.